Today we're going to learn how to use pH and pOH and concentrations of acids and bases to do different calculations. You will need your calculator, so go ahead and grab that before you move forwards. That way you can be practicing these problems as you go to make sure that you know how to use your calculator to get the same answers. And if you need help figuring out how to use your calculator for these types of problems, please get into contact with me so that I can help you out with that. Okay, so here is an equation that we are going to use to help us out. Okay, this is K sub W, that is for the constant value for water when you have reached equilibrium. So equilibrium, if you remember from taking biology, is the point at which things are equal, and so they're happening at an equal rate. And so our constant equilibrium for water is when the water is switching into these hydronium and hydroxide ions equally back and forth, turning into water, turning into hydronium and hydroxide, turning into water, turning back into hydronium and hydroxide. That's when it's equal. And when it's equal, that is on the pH scale 7, right? Neutral. So we can use this equivalency point to help us calculate the specific pH of a substance. Okay? So when you have your concentration of hydronium times your concentration of hydroxide, that will equal 1.0 times 10 to the negative 14th. So if you know one of these, you can calculate the other from this equation. Okay, and so each of these within the brackets here, that means the concentration of. Okay, concentration of this, concentration of this. Let's do an example. Find the hydroxide ion concentration of 3.0 times 10 to the negative 2 molar hydrochloric acid. Okay, so there's our equation that we just got. Okay, and we want to find the hydroxide ion concentration. So we want to find the OH. That is our unknown. Okay, we have the concentration of hydrochloric acid. Since it starts with the letter H, that lets us know it's an acid. So that means that's going to go in the hydronium because acids create hydroniums. So this concentration will go into this location in our equation. So let's fill out our equation with what we know. And this is what we get. 3.0 times 10 to the negative 2 times our unknown concentration equals 1.0 times 10 to the negative 14th. And now from here, we can just use our algebra skills to solve for that unknown. So to do that, we need to divide both sides by the 3.0 times 10 to the negative 2. That means that'll cancel off on this side, leaving our unknown variable. And then we do 1.0 times 10 to the negative 14th divided by 3.0 times 10 to the negative 2. Now, to do this on our calculator, remember you're going to need to use parentheses around this number. And on your calculator, you will need to use the EE button. Okay, if you need help with that, get into contact with me. When you pop this into your calculator, you will get out the answer 3.3 times 10 to the negative 13. Okay. With this, remember sig figs. So my problem gave me 2 sig figs. My answer has 2 sig figs. So put this in your calculator and see if you get the same answer when you round for sig figs. If you do not get this answer, get into contact with me so I can help you figure out how to use your calculator properly. Okay, so remember our pH scale goes from 0 to 14. Numbers below 7 are acidic. The further away you get from 7, the more stronger the acidity. So an acid with a pH of 1 is a stronger acid than a pH of 6. Okay, same thing in the other direction. Above 7 is a base. The further away you get from 7, the stronger the base becomes. So a base with a pH of 13 is a stronger base than that of one that is 8, pH of 8. Okay? And we can use the concentration to determine pH, and we can use the pH to determine concentration. Okay, so pH is French, and it stands for hydrogen power. So you can see the French term there. And so to calculate pH, you do the negative log of the hydronium concentration. So if you have your acid concentration, it's the negative log of that concentration. Here are just some examples of some common household substances and what their pHs are. So you can see a very, very strong acid is battery acid, but you can see that our stomach acid is really low too. It's less than 1, so that's a really strong acid as well. Vinegar, which is something that we eat in our food, is considered a weak acid. On the other side, we have sodium hydroxide. That is basically the main ingredient in Drano. So you can see that that is a very, very strong base. Bleach is another household base that is pretty strong with O for 12. Milk is a base, milk of magnesia. That's what people take when they have upset tummies. And that is considered a weak base. Okay. All right, so with using your log and when we're doing calculations where we need to do the opposite of the log, this is another example of where we need to know our calculator. So if you have a graphing calculator such as a TI-83 or TI-84, that's what I have showing on the screen here. You can see right next to the 7 is the log button. If you need to do the opposite of a log, so if you're doing your algebra and you need the opposite of a log, you have to press the second button and then the log button. And that will give you the opposite, which is 10 to the x. And that x is where you type in your concentration. So we're going to do an example so you can see that. Okay. If you have another calculator that is not TI-83, not TI-84, it doesn't look similar to the picture I have on here, just get into contact with me so that I can have a meeting with you, take a look at your calculator and help you figure out how to use yours. I'll be happy to help you try to figure that out. We'll do some trial and error until we get it right. Okay. So here's some more equations for you to add to your equation list. So if you want to calculate pH, here's the equation. You have the negative log of the hydronium concentration or the negative log of the acid concentration. We'll get you your pH. But we can also do POH. That's the negative log of the hydroxide concentration or the base concentration. And then if we take our calculated pH and our calculated POH, they will add to be 14 because that is what our pH scale, it goes from 0 to 14. So when you add together your pH and your POH, they will equal 14. Okay, so make sure you add this into your equation sheet. Let's take a look at some examples. Okay, what is the pH of 0.050 molar HNO3? Okay, so we know that pH is the negative log of our hydronium concentration. Okay, hydronium's for our acids. This starts with the letter H. That makes this an acid. So this is our acid concentration that will go into this equation. Okay, so to get this, we do the negative log of our concentration. And at this point, we've got our number plugged in. Now all we have to do is type this into our calculator. So you will just type in negative, press the log button, and then type 0.05. And you will get 1.3 once you round 4 sig figs. Notice in this problem we have 2 sig figs, so my answer has 2 sig figs. So our pH is 1.3. Okay. So based on our pH, is this acidic or is it basic? Hopefully you guys said acidic because it is below 7. And it's a pretty strong acid because it's really close to being 1. All right. What if we want to do the other way? We want to figure out the molarity. So we want to figure out the concentration. So what is the molarity of HBr in a solution that has a pOH of 9.6? Okay, we got to be careful here because we have a pOH measurement and we're talking about an acid, HBr. Okay, so here's what we need to do. First, we need to remember that our pH plus our pOH is 14. We know our pOH, so we can calculate the pH. Okay, so unknown pH plus 9.6 equals 14. So to solve for that pH, we do 14 minus 9.6, and so we get our pH of 4.4. Okay, next, we're going to put that into our equation. pH equals the negative log of our acid concentration. Okay, we know the pH is 4.4. We don't know the concentration. That's what we're solving for. Okay, so the first thing we got to do is get rid of the negative. So we will divide both sides by -1, and that gives us negative 4.4 equals the regular log of the concentration, which is currently our x. Now we need to get rid of that log. So in order to do that, we have to do the opposite of the log. So on the TI-83s, TI-84 graphing calculators, to do that, you would press the second button, and then you would press the log button. That's going to be 10 raised to the, and then you plug in your number there, negative 4.4, and then just hit the enter key. Okay? That's all you have to do, is second log negative 4.4 and hit the enter key. And you should get, once you round 4 sig figs, because we need 2 sig figs, you should get 4.0 times 10 to the negative 5th. Okay, so try that in your calculator, plug that in. If you do not get this answer, get into contact with me so I can help you figure out how your calculator works. Because up next, you have to do independent work. And so if you don't know how to use your calculator in the way that your calculator needs you to work with it, you won't be able to get the correct answers, even if you know how to use the equations. So please get into contact with me if you need some help.